This is our metronome synchronization project.
Synchronization is when two or more systems come into contact with each other and eventually begin to move together.
We are using metronomes placed atop a pine wood board that's placed atop soda cans. The soda cans allow for the board to rock back and forth. This rocking motion is essential to get synchronization to occur.
The motion of the pendulums generates a force onto the board, and since the metronomes and the board are connected by static friction, they move as one. This means that when the board moves back and forth, it generates one cohesive force on each of the three metronomes.
This small force is essential as it causes minute changes in the frequency, and as the frequency slowly changes, it causes the phases to creep closer and closer. Once the phases are the same, they are phase locked, and once they are phase locked, they will swing at the same frequency and at the same time as if started originally from the same phase.
When making this demo, we learned it was really susceptible to outside forces and internal forces that might mess with the locking. For example, having slightly heavier wheels might keep the system from locking in a timely manner, or any small deformations in the cans could keep it from locking altogether, as it would generate little amounts of friction that would overpower the forces generated by each metronome.
This phenomena of synchronization of physical systems was first observed by Christian Huygens, who built the first pendulum clock. He noticed that pendulum clocks placed on the same wall would eventually swing in time, or swing at the same time except 180 degrees out of phase. This is called anti-locking, and it occurs when one pendulum is swung to the left while the other is swung to the right. They still beat with the same frequency, just perfectly out of phase. We noticed this happened more often when we had more metronomes placed on the board.
We'll now demonstrate the metronome locking.